for the tap water from Tony's apartment.
Ronnie.
Ron.
Ronnie.
Oh, I had the wrong name.
Yep.
Ronnie,
Midtown 100
Midtown
10th Street. Okay, here we go.
10th Street. So we're gonna take, this is right out of his kitchen sink. So let's rinse this off real quick. Okay. We're gonna take 100 milliliters of tap water. There we go.
All right.
Okay. So we've got 100 milliliters of tap water. We're going to use a solution called orthotoluidine, or OTO. It's from a 5-way test kit, which is the same kind of kit you use to test a swimming pool or a spa for chlorine concentration. And that's what we're going to do. So I'm going to add 5 drops to the sample. 1, 2, 3, 4, 5. And when we swirl this around, you see the color change taking place. That's telling us that there's chlorine in the water. And there's no surprise that there's chlorine in the water because they use it as part of the water treatment process. City of Atlanta, really any municipality is going to use chlorine in a lot of ways for disinfection, killing bacteria and other organisms that are in the water that could make us very ill if we were consuming them untreated. So what this is telling us, it's not surprising that there's chlorine in the water. What we have though is, if you look at the scale, this is probably between 1 and 2 parts per million. This is the scale between, this is a ppm, parts per million. So it's definitely not up at the top. It's not rusty like the 5. It's not orange like the 3. But it is concentrated like the 2, yet it's got a little bit of the 1, the greenish tint of the 1. So this is probably a little bit below a 2. We're probably somewhere in the 1 to 2 range, like 1.5 or something like that, parts per million of chlorine. Now, between 2 and 3 parts per million is labeled ideal, but that's ideal for a swimming pool. So you have just about as much chlorine as you would find in a swimming pool in your
drinking water. That's what's been making me sick for 2 months.
And chlorine can affect your health in a lot of ways. It can affect your digestive health because it kills the healthy bacteria in your gut, right? Your probiotic health is affected by chlorine. It kills bacteria. Yeah. It can affect respiratory health. It can affect cardiovascular health. It can even be carcinogenic. Chlorine and its byproducts can cause cancer, and there's a lot of byproducts in our drinking water.
Yeah.
Now, chlorine can also affect your skin and your sinuses. It can just dry you out really bad too.
Right.
So even
that's how my face has got like how it's sucking in a little bit because I ain't been getting my water to fill it in.
Yeah, it's true. It'll basically suck out. Like you can end up like aggravating like if you have like arthritis. Yeah. It can even affect that because it's basically drying out your bones. Right. Your what do you call it? Your knuckles.
Joints.
Your joints, exactly. Thank you so much. So, chlorine can really wreak a lot of havoc. It's poison. I just tell people flat out.
Is that the only test we need to do?
Well, I'll show you let me show you a visual test. This is actually kind of interesting.
Okay.
So this test is a visual test for the sediment and the particulates in your water. Okay,
yeah, I've been getting sick for 2 months. You see my face, crazy, man.
So check this out. This test tube is labeled hard because most people, 85% of America, has hard water to some extent. Hard water is water with a lot of sediment in it. And that sediment can be a lot of stuff. It could be very natural stuff like the earth, organic matter, minerals, and even metal particulates that are in the ground. But it could also be garbage, refuse, solid wastes, you know what I mean, pollutants that end up in our lakes, rivers, and streams, like the Chattahoochee, for instance, right? So this is quinol sulfate. It's the precip buffer, and I'm going to add 5 drops to the sample here. 1, 2, 3, 4, 5. All right. Then let me put this down. I'm going to add 10 drops of potassium hydroxide. This is the reagent chemical. So let me add 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you could see some flourishes happening, right? But wait till I shake this up. So I'm actually going to cap this up, and we're going to give it a good shake. And what this does, this is called the precipitate test. We are actually precipitating the water, and any sediment and particulates that are in the water that you normally do not see unless there's like a water main break, right? And you get a bunch of gunk and sediment in the water.
Right.
You normally don't see this stuff, but it's in the water all the time. And what we're doing is we're drawing it out so that it comes into suspension and it actually becomes visible. So now, we've got some cloudiness in the water. We've got a foamy, bubbly head that is reactive. Basically, that is sediment that's separated out. And if you look, you can see little particles floating around in the water. And when we shake this, you can actually see them swirling around. See how you see all that stuff there? So if the longer we let this sit, I could have set this test up first and basically let it sit a while, but the longer we let this sit, the more cloudy the water becomes. It's called turbidity. The turbidity of the water is the cloudiness or haziness of the water due to small particulate matter.
Okay.
And this could also be, like I said, this could